Alrighty, so next to last problem, we're asked here to find the average value. That's something that we learned a while ago. We actually just took a test on that a couple of weeks ago, right? So that's this little equation over here. We're given our function and we're given our interval. So all we need to do is plug that in. We have our A and our B. Don't forget to do that 1 over B minus A. A lot of people left that off on the test, remember that? Okay, and then we evaluate it from A to B, our function. And then we have our dx at the end, okay? So in this case, again, we have sine and cosine. So we go back to that first chart that we were looking at. And we have odd sine. We actually don't have odd sine, right? So you could skip that one if you wanted, but let's think about it. So we do have odd cosine, which means we'd have to break this up into let's see, I'm gonna write this on the paper just to show you guys. We are gonna end up using odd sine, but I'm just gonna show you what it would look like if you attempted to do odd cosine. So when you're working these problems, please do not be upset if you're working the problem and then you realize like it's not working. It's not that you're doing it wrong. Sometimes it just takes process of elimination, okay? So let's just say you thought that you were supposed to use cosine odd, and it might work, but we'll see if it does or if it doesn't, okay? So we have our function. We have sine x squared cosine squared x cosine x. So let's just say you thought that you were supposed to use this one, okay? So I just split that into 2. So we know that we're going to replace this sine squared right here with 1 minus cosine squared x, okay? And then, wait, which one are we doing? We're doing, okay, we're doing the bottom one. Yeah, so we're going to place the sine squared with this, and we're going to replace cosine x with u. So, oh, I didn't have to break that up. I'm sorry. This way actually might work. So let me put that back. So yeah, so our cosine, sorry, so I'm gonna just write that as this for right now. Cool, so we know that our u is now going to be cosine, so this is gonna be 1 minus u squared, and then u squared. And then to get rid of our squareds, to get rid of these parentheses, we distribute this in, so we get u squared minus 4u, okay? So that actually puts us in the exact same position that this put us in here. Y'all see that? So that is the u squared minus 4u. So that actually both worked, okay? Because I have this written down, I'll do it both ways. But yeah, so let's just say that you didn't decide to go the odd cosine and you went odd sine. We use these top orange lines. We take the derivative of our cosine. Oh, wait a minute. I didn't take the derivative. Oh, well, I guess it doesn't matter. Oh, cool. That's cool. I actually didn't know that. I'm just pointing out that when I did it this way, I only used this first, wait, I was using this one. I only used this, oh no, I did use u. I plugged in, oh, that's what I was saying. I didn't end up using the derivative, so I didn't use du. So I guess that doesn't matter. I've never worked a problem like that before, but it seems to check out. So again, as long as you aren't making up math, you're pretty much good to go. All right, but at any rate, oh. No, I think all is well. Our u in this case would have been cosine, and we're plugging in I kind of just want to finish this one. So, sorry, if we're doing this bottom one, that's the odd cosine. That's what we decided to use. Because we're doing this integral thing, remember we still have 1 over b minus a, which gives us this 2 pi. And then we were evaluating it from negative pi to pi. But when we change it to our u, we have to do our change from our integral. So our u in this case would be cosine x, and we're plugging in negative pi and pi into cosine. So if we think about our unit circle, here is pi, that's negative 1, 0. So we're going from, oh yeah, it still works out, negative 1 to, oh wait, sorry. Oopsies. This first one is, oh yeah, sorry, so this first one is, yeah, they're both negative 1. That's just gonna go away and it'll give you pi. Yeah, so they'll both be negative 1. You can go back to your even and odd functions. Remember cosine starts at 1 and it looks like this, right? Cosine is an even function because you can take it along the y-axis and fold it over, which means that this negative on the inside will actually just disappear. So cosine of negative pi is the same thing as cosine pi, and cosine at pi, cosine is x, is going to be negative 1. So again, here we'll still get the same answer, which is 0. If we're taking the integral from the start to finish and it's at the same number, we're gonna get 0, right? Because remember, the interval is just adding up the area underneath that space, but there's no area in between there, so you end up with a 0, okay? Cool, I just wanted to make sure that worked out. But yeah, okay. So anyway, you could also do it this way. Essentially, you'd go about the same way, and once you got that interval, honestly, you wouldn't even have to work this part out. Once you saw that the new interval was going from the same spot, then you knew it was going to go to 0. So that's 8.